Welcome to the masterclass on PydanticAI, a new framework for building AI agents. In this masterclass, we're learning about the core features of PydanticAI and how to build effective agents using simple Python code. We aim to hit all key features of the framework with plenty of examples, so by the end, you have the confidence and knowledge to build your own. Today, we're taking a detailed look at how to customize advanced model settings to optimize your AI application performance. Model settings allow fine-grained control over model behavior, enabling us developers to balance accuracy, speed, and resource consumption for specific use cases. We'll explore how parameter adjustment impacts model outputs, from temperature to top P settings for more specialized configurations like complex window optimization and token management. And stick around, because I'll show you a nifty way to encourage or discourage the use of certain tokens by your model. Before we dive further, let's talk about the importance of model settings. Model settings are a configurable parameter that control AI behavior. They're important because they enable flexibility. Settings like temperature and top P allow tailoring agent responses to different tasks. Model settings are configurable parameters that control AI behavior. They're important because they enable flexibility, from deterministic, factual to more creative. Then there is the cost control. Parameters like max tokens and reasoning levels can help manage operational expenses by limiting output length and computational resources. And finally, logit bias, a fancy term that can be used to suppress specific tokens or promote others, helping prevent unwanted outputs or guide the model toward desired response patterns. Today, we'll work on 3 great examples, starting with a hello world, then moving on to more complex examples and looking into model-specific settings for OpenAI and Gemini models. We will cover most of these settings, but as always, if you're working on a specific problem or need tighter adjustments, please check the latest documentation. Let's dive in. But before we go, let's take a look at the new school program that I've started. If you're looking to elevate your career, startup, or business, AI software developers is the best investment for you, and now is the perfect time to act. We're looking for anyone who is ready to master AI at an enterprise level. You don't have to be technical, but it will help if you have some basic coding skills. More importantly though, we're looking for motivated learners. If that's you, this is your chance. Become a member today and unlock the most powerful AI content to take your skills to the next level. Okay. Let's start with our first example. We'll explore some basic model settings, and as usual, we'll start by importing our models. So from PydanticAI models, we're going to use the OpenAI model class. The first thing that we're going to do is we're going to define our settings class. Let's explore our model settings. So model settings is from Pydantic. The first one is the max token. So max tokens you can set to a number, limiting the number of tokens produced by the model. This is a great way to cap your expenses and limit the model responses to that number. For instance, if the model is consistently generating long answers and you simply just want a brief answer, A, you can specify that in the system prompt, and B, for cost optimization and AI ops purposes, you can also bring it here with the max tokens at a number that makes sense for you. The model setting class provides a number of parameters, and by the way, this changes quite often, so make sure to check the latest that is from the OpenAI and PydanticAI APIs, because new parameters get added every day. The next one will be the temperature setting. And with the temperature, 0 means less creative and 1 means the maximum creativity. So this range goes from 0 to 1. For scientific and math related situations, you might want to drop it down closer to 0, so it's more factual and less creative. For creative writing, script writing, marketing, you may want to increase the creativity level. The next one is the top P, which is an alternative to temperature. In this case, the model considers the results of the token with the top P probability mass. So 0.1 means that only the tokens comprising the top 10% probability mass will be considered. So it's a different measure. You can use one or the other, but not both. So make sure to include that. Next is the timeout. This is also very important. If certain calls are taking longer, you can limit this, and the number is in seconds. And that would provide a cap for your user experience so that your API calls do not take longer than your SLA, for example. Next, we're going to use a random seed. Now, the seed parameter, in my opinion, is one of the more important ones, because by specifying a seed, you, in theory at least, you provide a little bit more consistency to the outputs that are produced, because the model will take this. Let's keep in mind that a lot of this stuff is still very non-deterministic. And just by providing this random seed, you will add a little bit of determination to the answers. It will not be 100% the same answer every time. Next is the presence penalty. And this is to penalize tokens based on whether they have appeared in the text so far. So that includes diversity of the language. So if you don't want certain tokens to be repeated, just increase the penalty to 1 so that there's different words used across the answer. Next, frequency penalty is a similar parameter. So we've included these 6 or 7 parameters in the settings, and now we're just going to define our math response result type. Today, we're building a math agent for primary school students. This assistant will be helping with operations such as addition, multiplication, division, and subtraction. Therefore, the response type now we're going to define that will be a structured Pydantic class that our agent will respond to our questions. Let's go ahead and take a look. We're going to have an explanation, that's a string, answer, that's a float. There's going to be a number of steps, difficulty level, and practice problems for later on. Then we're going to define our model. The tutor model will be an OpenAI, passing the key. While creating the agent, this is the important thing, on line 55, we're passing the model settings that we just created. So be careful, pass the model settings so that the model complies with the settings that were already defined. Line 55, we are defining the model settings. Continuing on line 57, we're now defining 4 tools. Each operation will be a separate tool. So we have a tool for add, subtract, multiply, and divide. We're going to include all of these tools when we run our agent. Now we're going to write a descriptive system prompt. This is important. Take a little bit of time to make sure that our agent understands its task and it has a clear set of steps how to operate and how to answer questions. There will be interacting with potentially younger audience, primary school students, or their parents. So it's important that this agent assumes that role and persona and understands the tone and the style and the structure that they need to provide answers with. So that's why we're including be friendly, be positive, be encouraging, suggest practice problems, estimate the difficulty, and then provide the answer in a structured format as we've provided the result type class. Now we're continuing with our main loop, and once the main loop is done, we're going to run our app. And for this project, we're going to use Poetry. So once we are done with our script, we're just going to save our script. This is our hello world.py. And then we're going to open an integrated terminal or open your favorite terminal and run Poetry, run Python 12.1 hello world.py. And the first question from our agent is, I'm a math tutor. What can I help you practice today? And we're just going to ask a simple question. What is 10 plus 20? Once we run this, our math agent will respond in the blue type. Let's take a look at this. So first of all, it's structured, compliant with what we already asked it to do. To solve 10 plus 20, we start with the number 10, then we add 20 to it. This means we're combining these two numbers. So it's a simple language, easy for a primary school student to understand. The difficulty level is easy. Practice problems. There are a couple of practice problems. So that's really good. Let's continue now with the other problems. Our next problem is, what is 1 plus 1? So we get a similar answer. Again, the difficulty level is easy and the practice problems are 2 plus 2, 3 plus 1. Result is again provided in a structured way. Now, I'd like you to take a notice of one specific word that is being used in both answers. And that word is the solve word. There's nothing wrong with it, but I'll demonstrate you one more setting parameter that we can use. And with this next set, take a look at that. Both answers start with to solve and then 10 plus 20 or 1 plus 1. Let's imagine that we would like to remove certain words from the answers that the LLM generates. How can we do that? And the simple answer is through the logit bias. What is the logit bias? Let's go ahead and open the OpenAI's logic bias page. You can find it at this URL, and I'll include this in the description of this video. But read up this document and understand a little bit what logic bias means. It's an optional parameter that modifies the likelihood of specific tokens appearing or not appearing in the answer. It's a JSON object that is based on the token ID, and it ranges from -100 to +100. -100 completely disables that word from the answer. +100 strongly encourages the use of a particular word. So think of brand ambassadors, think of marketing agents, and some of the words that you'd like to encourage your agent to use. So those are all possible with the logic bias. This is from the OpenAI website, and there's a very handy tokenizer tool. So click that link. And once you get on the tokenizer tool, here you can type any word, and then you can get the token ID for that word. So for example, type solve and then go and click the token ID, and you will see that for the word solve, the token ID is 117273. Copy that ID somewhere, because what we're going to experiment with now is we'll pass this array of logic IDs with their weights to the model settings, and in effect, we'll ask our model to not use the word solve and see what it will use instead. All right, copy that number. You can also experiment with the word add or other words. You can copy them as well and just see what happens. Back in our code, close the terminal now and go back to our settings. After the very last setting, let's add one more setting, and I'll show you how to add the logic item here. So let's go ahead and modify the likelihood of specific tokens appearing or not appearing. So we can remove words such as addition, solve, irrational. Here are some of the logic IDs. I include this as a comment, but the actual line will be on line 49. Let's take a look at line 49. What we're excluding is the words addition, solve, and what we're including or what we're encouraging is the word amazing. So if you look at the weights, we're asking amazing to be used, and we're asking for solve in particular be taken out with the logic bias of -100. This is one way to experiment. Let's save our file now and rerun our agent and see what results we get. Back at our model, we see our previous results. So I haven't cleared the terminal. We're going to run our test script one more time and ask the same question. What is 1 + 1? And let's see what words the agent chooses to use this time. Instead of to solve 1 + 1, now the agent rephrased that and used to find the sum of. This is a replacement of solve versus to find the sum of. And I think that's a really interesting use of this parameter inside the settings. This is our Hello World example, and you can experiment with this, and it's a lot of fun. It's a good way to potentially take out words that you don't like or add your brand words to the model responses. Now let's move on to our next example. We're going to do the OpenAI model settings. OpenAI model settings are slightly different than the other models. So let's explore how OpenAI handles it and how PydanticAI is giving us an opportunity to basically customize our OpenAI model settings. In this case, we're just going to import OpenAI model settings from the PydanticAI models OpenAI. And here first we're going to create the OpenAI model, and next we're going to do the model settings, but this time we're using OpenAI model settings. And here we're going to go with max completion tokens of 500, top P1, frequency penalty, presence penalty, and now we're going to create constraints on the effort and the reasoning. So this is OpenAI specific, especially if you're using a reasoning model. This is one way to limit the computational resources and therefore limit the cost of the queries. What we are saying here is OpenAI reasoning effort is low. The other thing you can use is a unique identifier representing the end user, and the OpenAI can monitor and detect abuse potentially. So this is a good way to put guardrails in your usage. We're also setting the temperature that is already supported by many of the models, but these 2 or 3 different parameters are specific to the OpenAI setting models. And that's why I included this as a separate example. What we're building here is a customer service representative agent, which will answer customers' questions about orders, shipping, refunds. Here is the assistant definition. We're going to use the CSR response result type from the assistant. It's a structured Pydantic class. And now we're building the system prompt, taking it a little bit more seriously. Now with these set of examples, we'd like a very descriptive and step-by-step system prompt so that our answers can be significantly improved through a great system prompt. So what we're saying is you are a professional and emphatic customer service agent for an online retail store. Your role is to assist customers with their inquiries, resolve issues, and ensure a positive shopping experience. Always address customers politely, and here's a structured way to provide a response using the CSR response class. Pretty straightforward single agent system. We're going to define our main loop, and once the loop is done, we're just going to call our main function and execute our model and test it with a couple of questions. Now that we're using the settings, agent has been started with our settings. So now we can execute our agent and make sure that these settings are taken into consideration. In our favorite terminal, let's type poetry, run Python 12.2 model settings OpenAI. And once that's done, I am your customer service agent. What can I help you with? Where is my order for a pair of Nike sneakers is the question. And let's see what the agent responds with. By the way, this is obviously not connected to a data source or into a production system. So the agent is largely making this answer up according to the rules, the system prompt, and the response type that was passed during the agent creation. We have a detailed answer. Thank you for reaching out. Happy to assist. And the structured response is still there. This is based on a really good system prompt. That's one tip for your agent is be careful on the system prompt. Do ensure that you have good coverage on the system prompt. Next, I'm not satisfied and would like to return the item. Let's see what the assistant will tell us about the refund process. When can I expect a refund? And let's go ahead and see what the agent says here. Thank you for reaching out. I'm sorry. Okay, good. Regarding your return, once we receive the sneakers back at our facility, the refund is typically processed within 3 to 5 business days. That sounds pretty reasonable. That looks like the agent is doing exactly what we asked it to do with the model settings that we specified. Okay, that's also very, very good. And it is a good customer service agent example that potentially you can take and use as an example for your next project. Let's move on to the next example in which we're going to examine the Gemini settings. Gemini settings are slightly different than the OpenAI settings. Let's explore what you can do. Quick tip here is that always go and read the latest documentation from the vendor, OpenAI, Google, Amazon for their models, and ensure to understand the model settings that that particular model offers. There are slight differences, and it's a challenge for any framework, be it PydanticAI or LangGraph, to provide a settings model that complies with all different models. So that's going to be a little challenging. That's why usually it's a subset of the settings that are most commonly used by multiple models. But if you'd like to get really deep, or if you're working on a specific problem, my recommendation is to read the vendor documentation, read the latest documentation or the version that you're using, and from there determine what settings make more sense for your use case. But here we're creating a class called Gemini model settings, and here we're setting the Gemini temperature at 1.0. So we want a little creative. So here's how we inspect the model settings and what is available. As you can see, we have max tokens, temperature, top P, timeout. Parallel tool calls is another thing that you can explore and enable or disable. And there are reasons why you would like to do that, especially if the parallel tool calls are either getting into a race condition or they're expending too many API calls. You may want to limit that and want one tool to finish before the other starts. Presence penalty, logit bias, Gemini safety settings. So this is one thing that we're going to explore, not available in other models. So let's explore that because it's specific to the Gemini model. Here are the safety settings. So there are many safety settings, but in particular, what we're going to do is 2 settings. In the first one, category will be harm, category harassment. So block low and above. Anything that is low, medium, and high will be blocked from the response. Anything that has to do with harm, category, or harassment will be blocked out. The model will not respond. The second will be the harm category, hate speech. Anything that is low and above, low, medium, high, will be blocked from the response. And here you can control the level of responses from your model and how that shapes up with your particular use case. In some cases, you may want the model to be more liberal, but in many business enterprise settings, you will want to have tight controls over the language, especially for hate speech and harassment. This is a good way to limit that. Gemini safety settings, it's an array, and each item of the array is a hash with the keys, category, and threshold. So now we're going to create a typed response type for our agent. In this case, we're just going to create a brand ambassador agent. It's a third example. It's a very common use case and in high demand by the community. Feel free to grab the source code and make this your own. This is something that a lot of people are working currently. It's a little chatbot for a website, could be a brand ambassador. So you want your brand ambassador to use the terminology and to use the words that are appropriate and to exclude any potential harm or bad language from the model. Because at the end of the day, once you release this agent, you have little control of the input that the user provides. For example, if the user provides hateful input or accidentally types a word, you don't want the model to respond in kind. You want to filter out these potentially harmful or hateful words from the response. Okay. Now we're going to write a descriptive system prompt. So let's go ahead and do that. You're a skilled brand ambassador representing a company to potential customers. Your role is to engage with users, answer their questions, promote the brand, and maintain its distinct voice and values. That's really good. Maintain unique voice, tone, personality, follow established brand guidelines. We're not telling what our agent is or the brand is. In a production system, you'll likely train this agent with your corporate guidelines. Say that you're a Tesla or a McDonald's brand, and in that case you would want to feed the marketing guidelines or the conversational guidelines perhaps in a RAG system, so the agent is deeply familiar with the answers to common questions. But in our case, this should be sufficient. It's a good system prompt to start and test the model settings. Now we're writing our main loop, and after the main loop, we're just going to execute our agent and then launch the terminal and ask a few questions and see how we do. Once the main loop is done, let's just invoke our agent. Open your favorite terminal and run poetry, run Python 12.3 model settings Gemini. I am your customer service agent. How can I assist you today? So let's start a simple query about McDonald's. What can you tell me about McDonald's? And let's assume that the brand ambassador here will be a McDonald's representative. And let's quickly take a look at the outputs. The customer service representative will assume the personality of the brand and should respond with language that is positive, helpful, and encouraging the customer, hopefully, to do business with the brand. As we can see, hey there, so glad you asked about McDonald's, smiley emojis. This is really good. They're providing input about Big Mac, crispy chicken nuggets. It's a good answer for a brand ambassador. There is emphasized convenience, personality traits, friendly, approachable, positive, enthusiastic, family-oriented, suggested products, Big Mac, world-famous fries, chicken nuggets, and so on and so forth. And there is no next step. There is no follow-up question. Let's continue our conversation and ask a follow-up from our end. Why not Burger King? This is coming from Gemini, and the settings prohibit any harmful or hateful responses. This is a fair question. Why lots of places grab a quick bite. We really pride ourselves on offering something special using premium, fresh ingredients. So emphasis is on positivity, on brand value, and never on bashing the competitor or potentially saying bad things about either the industry or other players within the industry. So it's a great test. And it's a good way to limit the ways in which the models can produce outputs. So think of your settings, think of your business applicability. Are you working with children? Are you working with perhaps disadvantaged communities or people perhaps that could be vulnerable to that kind of language? This is a good opportunity to think about these safety guardrails and embed these safety into the model during the design of your agent. Let's move on. Model settings can help you customize the behavior and operational efficiency of your agents. There's no question about that. By adjusting various parameters, you can fine-tune how your AI responds, balancing between deterministic answers and creative explorations while managing computational resources effectively. That's key. PydanticAI provides support for most model settings. As I mentioned, a lot of times it's going to be a subset, so it pays to look at each model's specific settings for greater flexibility and fine-tuning of the settings. But PydanticAI allows developers to easily implement and adjust these configurations within their applications without additional complexity. There is so much more to explore, so be sure to continue to watch this series and what's coming next. But for today, this is a wrap. I hope you enjoyed this tutorial and you learned how to build more engaging AI agents through customized model settings. If you get value from this series, please consider subscribing and giving the video a thumbs up. Thank you and see you in the next one.